7, 6, ignition sequence start. 3, 2, 1, ignition.
And in my physics class, we did an experiment about the force of gravity. And in this experiment, we used a soda bottle to represent a rocket. And we were studying rockets and how they would escape the force of gravity.
Like all astronauts, we need to know how a rocket works, and we need to know what it needs in order to take off.
Students worked with the major formula, which is the universal gravitation formula, which is F equals G m1 m2 all over r squared.
So we wanted to conduct an experiment that would kind of show a model of a rocket ship. So we took this soda bottle that was pre-made, and it had like these fins at the bottom, so it had the shape of a rocket ship. And what we did is we filled it 2/3 with water, so it could act as a fuel, because we know that rocket ships use fuel to get to space. And we left 1/3 of the bottle empty with air, so that we could connect it to an air pump, and we could compress the air into it.
Because the bottle is rigid, it won't explode, it will force the pressure through the weakest point, so once sufficient air had been pumped in, it would force the water down, blow out the bung from the bottle and shoot the water out. And we filmed this using slow-mo film.
We measured the time because when we recorded, we managed to get the time of how much it took for it to go up and land. And we also got the distance out of that, and we had approximately 80 meters. And so when we got the distance and over time, we managed to find the speed of how long it took for it to come back down.
The point was we wanted the kids to calculate the forces involved. So initially we measured the mass of the bottle of water, and then with the acceleration for Beirut, the gravity that they had calculated, we worked out the weight. So we knew the force that was holding the bottle down. So then we filmed it in slow motion. We estimated how high it went, which is about 80 meters. We could time it from the timer on the film. So with having distance and time, we could work out speed, or rather velocity, because we had direction.
We also needed to calculate the thrust. We wanted to see how much force was pushing upwards to get the rocket going. And we looked at the distance once it was launched. We measured the time taken, so we could find the speed, the velocity, the initial acceleration, which was 0. At the time it wasn't moving. We also had to see how quickly it accelerated, so we could do a series of formulas to find the exact thrust. Now we noticed that the thrust was about 5 times greater than the force of gravity, which means that it was basically able to escape from the gravity.
I really enjoyed this experiment because it just gave me a visual image, and I'm a visual person, so this helped me develop my understanding.
I think the unit is much easier to understand once we did this experiment.
So it was a good, fun combination to the unit.
'Cause it's all of this science, well, I don't understand.